Good morning, 你好. Welcome to Blockchain and Lindy Chen channel. My name is Lindy Chen. I'm very excited to be here and share my insight about blockchain with you. In the last video, I shared with you establish interaction with off-chain data source, identify use for off-chain services. In this video, I will share with you identifying the problem that the smart contract is to solve and the participant and the contributor required to arrive at the outcome. All projects should start with a clear specification of what you want to achieve, otherwise you will waste time adding unnecessary features and inviting scope creep. Identifying the problem that the smart contract is to solve and the participants and the contributors required to arrive at the outcome. Smart contracts activate transaction within the application on the blockchain. It is likely that there may be multiple smart contracts activated within the application, and each will rely on the specific set of events to activate it. Each set of events can be considered to be a problem that the smart contract will endeavor to solve. This is where the if-then logic will determine the next course of action the smart contract will activate. It may be that the desired business outcome is not achieved. However, the logic coded into the smart contract will move to the next action it has been programmed to do. For example, if the set of events, aka problem, is a purchase that requires payment once the order has been confirmed, and the payment is rejected, then the next step is to suspend the order. Several problems are involved in this transaction. Receipt of an order, determining whether the item is available, calling for payment, what to do when funds are not available to make payment, activating agreement. As we now know, a smart contract is not a legally binding contract in the Ricardian context, but rather it does a few things. It will reflect the agreed terms and conditions of the agreement. It will use the terms and conditions as the logic to action the agreement. It will return an immutable record of the actual transaction on the blockchain. Agreements can be complex agreement or simple offer and acceptance agreement. The level of complexity will be reflected in the if-then logic that is coded into the smart contract. One of the characteristics of smart contracts when activating legally binding agreement is that the terms and conditions laid out and stipulated in the smart contract cannot be disputed, as they only record whether the stipulation have been followed or not. Use case of smart contracts. Previously, we discussed a range of applications and that they are only limited by the creator who creates them. Consider problems set of events that could be solved within these applications. The following graphic nicely demonstrates use cases of smart contracts by complexity. Smart contract, simple to complex. Ways smart contracts can be applied. Previously, we also discussed ways to apply smart contracts to solve problems, providing a common language, reducing transaction costs through automation, managing risk and fraudulent behavior, automating intermediary roles, disintermediation, facilitating direct business relationships, facilitating ownership of personal data, accessing big data. Again, this is not a complete list, but will provide some insight into the endless sea of problems to be solved. Alignment to the business model. Organizations are presented with a seemingly definitive source to refer to when identifying the problems that are to be solved. The approved business model should detail the customer, internal and external value proposition, and the key activities that must happen to deliver that value. Smart contracts activate transaction within a blockchain application, so to identify the transaction where a smart contract can be used to effect, we can refer to the building blocks of the business model for guidance. 1. Target market segment. 2. Value proposition. 3. Communication, distribution, and sales channels. 4. Maintaining customers' relationships. 5. Converting value proposition to revenue streams. 6. Accessing the key resources required to create and deliver value. 7. Performing the key activities required to create and deliver value. 8. Facilitating key relationships in the value chain. 9. Managing the cost structure when delivering value. In the table below, let's take a closer look at the building blocks and some problems that they may present in the context of Internet of Things. Business model. Market segment. The problem is engaging with the right customer. Value proposition. The problem is relieving customer pain point like costs in time, money or effort, frustrations, annoyance, underperforming solutions, risks, process mistakes, barrier to adoption. Creating gains for customers, creating saving in time, money or effort, outcome that exceed customer expectation, improved performance or quality of service, better accessibility and usability, match customer success data, make adoption easier. Channel. Problem. Raising awareness of goods and service, helping customer evaluate the goods and service, placing an order and making the purchase, delivering the value proposition to customers, providing after-sales support. Customer relationship. Problem. Customer acquisition, customer retention, upselling, revenue streams, providing ways to generate revenue stream easily, asset sales, usage fee, subscription fee, lending, renting, leasing, licensing, advertising, brokering, dynamic pricing based on market conditions. Key resources. Accessing or leverage the key resources required to deliver the value proposition. Physical resources, intellectual resources, human resources, financial resources. Key activities. Cost-effective processing of transaction. Interoperability with other networks, platforms, and data sources. Problem solving for customer hotspot. Key relations. Addressing motivation for creating partnerships, creating economics of scale, reducing risk and uncertainty, access to specific resources and activity, cost structure, minimizing costs, economies of scale, economies of scope, participants and contributor. Consider that once the logic has been decided and agreed, then decision-making use if-then logic can be programmed into the code of the smart contract. Participants and contributors could be narrowed down to the parties to the agreement or the creator of the smart contract specification. Once activated, the smart contract can act autonomously, performing the actions that were programmed in a transparent and incorruptible ways, replacing the requirement for further decision-making by humans. Consider this sequential development flow of a smart contract as a guide to who will be required to participate and contribute towards the creation of a smart contract. This escalation assumes that the business model has been crafted and approved. 1. What type of transaction will the smart contract activate? 2. What terms and conditions will apply to the transaction? 3. Obtain approval for the terms and conditions with any relevant stakeholders, authority, or legal advisor. 4. Determine the business rules, if-then logic. 5. Code the logic into the smart contract software and test. 6. Review the smart contract outcomes to ensure they are behaving and performing as expected. From myself, the team at China Direct Sourcing, the team at Phison Technology, and the team at Blockchain Collective, thank you for watching this video series. If you like what you see and hear and want to know more about it, please subscribe our channel and contact us. Good luck with your blockchain learning journey. Enjoy the program.